Hello. I've been doing some work analysing GPS speed over ground and course over ground information in order to draw polar diagrams showing how the boat performs depending upon what the wind direction is, but also in the hope that by studying this data I might be able to deduce the wind direction without actually having a wind sensor. What I also wanted to know was the boat heading, but we don't have a compass on the two test boats that are being used at the moment. And Roger's boat, which is not yet ready, or will have a compass on it, it's not yet ready. So I thought there are technical reasons why we can't change the software in the two test boats that are being used at the moment. So I thought what I'd do is make a standalone compass logger and just tape it onto one of the test boats in order to get compass data as well as GPS data. And we've done that, and this video is about the software that I've been writing in the last couple of days to visualize the results of that compass and GPS data. So I knocked up this box, which has a compass and an Arduino data logger. These Ardulogs are rapidly becoming my favourite tool for doing short little experimental things, because they can be programmed in C like an Arduino, and they bring out quite a large number of pins so that I can easily interface it to things. So this thing will run off a PP3 battery for 4 hours, which is enough for most things, and I've got it set up so that it waits for me to press this button so that I can sync this to a known clock time, and it then just logs the compass information every second until the end of the test, and I can then sync it to another known clock time. Because the actual timing of the Arduino is not amazingly equal to real time. I put this logger on the smaller boat, the boat 12, with the one with the blue sails, which is not intended for use as a real microtransat attempt, but it sails really well compared with this heavier boat on the right. So we ended up with an NME file containing GPS data and another text file containing compass data, and the requirement was to visualize this, to synchronize it also with a video of a test trip on a lake. Some of you, if you've watched earlier videos, will have seen this visualization which I did here to visualize the compass as the boat rolls and as the heading changes. That arrangement, this display here is running in a Chrome browser using HTML5 and Canvas. The arrangement looks like this. So we had the compass data coming in over a serial line, either directly from the compass under test or via telemetry from a boat under test. And it was read by a program written in JavaScript running in node.js, and then the data was passed via a WebSocket to an HTML5 JavaScript program running in a browser, which displayed it on the screen. I sort of wanted to replace this bit of it with something that read two files and stuck them together. But I didn't want to use node.js because I don't know a great deal about it. So I wanted to do this, which is to have a PHP WebSocket server which read the two files, the compass data and the GPS data, stuck them together and spat them at one reading a second over the WebSocket to the browser. So my first problem was that I had to work out how to support WebSockets in PHP. There are lots of off-the-shelf packages for doing this, but like all off-the-shelf packages, they're usually very complicated to install and involve installing 5 other things that you don't want. And I wanted something simple, so eventually I found on the internet an article by this woman here, which has a download of a very simple program that supports WebSockets in PHP. So I'll put a link to that in the front of the video. So I used that, and it worked fine. So what I've been doing in the last couple of days is writing that WebSocket server, and also adapting the HTML5 browser software to do what I wanted it to do. So I've got the PHP web server here and the HTML5 JavaScript thing here. I'll show you how it works. So what we've got here is the PHP WebSocket server, which when it's running spits out data in this format here, which is a compact form suitable for sending over a radio telemetry link. And I'll just start that now. And then we have the HTML5 program, which is now reading this data, which is being sent to it once a second, corresponding to the rate at which the data was originally acquired. And if I just spool on a bit, because the start isn't very interesting, because the boat was sat stationary at the base camp. So what we've got here is the real trip of the boat across the lake being replayed in pseudo real time, and the compass data on the left showing how the boat is rolling and pitching and how its heading is moving. This display here is a Google Map display. One can have it as a road map or a satellite map, and one can move it around and scroll in as one wants to. And this is running directly off my PC with no web server. At first I thought that Google Maps API was not suitable for that purpose, because I thought the API key restricted you to getting information from a web server, but I discovered this isn't actually true. When you apply for an API key, you can say that you want it unrestricted, in which case a Google Map will work perfectly well from a piece of HTML actually running on the PC rather than running from a web server. So that was helpful. And so long as we keep that Google API key a secret, there's no danger involved. So here Dick is launching the boat, and you can see him coming down the steps here, whilst Robin is filming it.
$14.39, and boat 12 is just approaching the orange buoy. With that Mobius camera, how do you get the video out of it?
It goes onto a little micro SD.
You can take the SD card out, can you?
Yeah.
Because I brought with me today a PC and an SD card reader.
If you've got the right USB cable,
Yeah, I've got that.
you could it'll look like a hard disk, so you can.
Oh, no, I haven't got a micro SD cable, but if you can take the SD.
Hit Delta.
Yeah, that's how it is.
What do you want to do that?
Well, because it's doing exactly what Snoopy did.
Yeah, exactly. Yeah, but it's better than that.
He's just getting there quicker.
Getting there quicker.
The logic, by the way, of waypointing is completely wrong. I mean, it should say, I'm going to Alpha, but then it should record, I've got to Alpha, now I'm going to Bravo, etc. It shouldn't just say, I'm in a box, so I'll go somewhere. should do things in sequence. You could have it in a row. It's turned.
Looks like the other one's going to hit down again, doesn't it? So what do you reckon if he does the same again, take him up?
You've got to see whether the boat as well comes back to take.
Yes. No. That looks... That's a compensation job.
The boat as well, definitely in the delta. Sorry, boat in definitely in delta.
So they're both coming home. They're having a race home.
Just toggle it, chuck it out again.
Well, it's been an absolute nightmare preparing this video, in particular syncing the compass and GPS displays to the video. I had to stretch the former by 5% to make them fit, and I found it quite difficult. Even though there are two very marked turns in the boat's track, which you'd have thought could easily be used to synchronize things, I found it very difficult. And there's no doubt that just the Mobius camera with its view of the rudder actuation is pretty good if you want to know what the boat's doing and what the sails are doing and so on. But of course we won't always have that camera, and the point of this visualization is to show me what the autopilot would know in a real situation. And also, of course, we can use that visualization on a laptop shoreside when we're getting telemetry via a radio link. So the work has been quite useful, but it's been a first-class pain making this video. Anyway, thanks for watching.